So today we're going to take a look at solving trig equations. So in example, if we have equation 1 and equation 2, and they're two similar things right here. The sine of x equals 1/2, so we're looking what angle gives us 1/2. And the equation in 2, we have the inverse sine of half equals x. Again, we're saying what angle gives us half. But are these equations equivalent? Well, the answer is no, because this first one, we want all values. But when remember we're talking about inverses, we use our restricted domains. So remember when we were talking about inverse, and I think we said sine was over here, we only use the values that are in quadrant 1 and 4. And that's what this talks about right here, is on the unit circle values. Again, if we want to solve for everything, there's multiple values where our sine is half, right? Because on our unit circle, sine is y. So there's 2 spots here. But if we're doing just the inverse, it's restricted to just our 1 over here. So if we were to solve this in general, so okay, our sine is 1/2. So if I was to draw, where is our y value half? It's half here and here. So what's opposite half is this is pi over 6, right? So what are these actual angles? Well, in the first quadrant, it's pi over 6. But in the second quadrant, it's 5 pi over 6. Now, if I want to know all values, when do I get back to the same spot? If I go a full 360 or 2 pi. So every 2 pi k, I would end up there, and every 2 pi k, I would end up here. Now we want the cosine half. So cosine is our x, right? So here would be positive half. Well, what is this? We're at 3 over 2, right? And that's at 3 over 2. So these angles, our reference angle is pi over 3. So in that first quadrant, it's pi over 3. And then again, we get back there every 2 pi k. And in this fourth quadrant, that's 5 pi over 3. And we get back there, excuse me, every 2 pi k. Apologize for that. Now, where does our tangent equal 1? Well, that's when our x and the y is the same. Well, that would be when we have our root 2 over 2 and root 2 over 2. And then down here again, right? Because this would be negative root 2 over 2 and negative. And a negative divided by a negative is a positive. And you might be like, well, Miss Husing, why doesn't it work in this quadrant? Well, that would be a positive divided by a negative. That gives us negative 1. So this is pi over 4. But what do you notice? It gets back here at pi, right? It repeats itself. So rather than say 2 pi, we can say pi over 4 plus pi, where k is our integer there, because our period of tangent is pi. So here's that stuff written up again, and it's the exact same thing that we did above. So if we have to find all the solutions where the cosine is negative root 2 over 2. Okay, so cosine is our x, so that would be right here, negative root 2 over 2. Well, I know that this is a pi over 4, so what is this actually? Well, in this quadrant, it's 3 pi over 4 plus 2 pi k. And down here is 5 pi over 4 plus 2 pi k. So where is our sine equal to negative 1? Well, right down here is where our y value is negative 1. So that angle is 3 pi over 2 plus 2 pi k. And now we want 1 over root 3. And tangent, again, I always think tangent's a little tricky. So is that a triangle when it's half root 3 over 2? Or is that a triangle where it's root 3 over 2 and half? Well, y over x, it has to be this one, because that would be half over root 3 over 2. So our tangent is positive. Okay, so half root 3 over 2. And again, it's down here again, but that's after pi. So this is the one where we're just adding pi k because it repeats itself. So what's opposite half is pi over 6. So this would be pi over 6 plus pi k. Okay, so when we take a look at solving this, you want to isolate the trig function on one side. And so similar to solving equations, we're solving for our trig function though. Rather than solve for x, solve for the trig function. Find the corresponding angle, consider domain restrictions, and write solutions. So this says all values. Okay, so how do we get the sine by itself? We'll divide by 6, divide by 6. So we have the sine of theta This would be then root 2 over 2. So where is our sign positive? Our y value is positive here and here, because sine is our y. So these are pi over 4s. So it would be pi over 4 plus 2 pi k. And what is it over here? That is actually 3 pi over 4 plus 2 pi k. So this next one we want to know what are the x-coordinates of the point of intersection. So where does 3 plus 2, the cosine of x, equal 2? Well, let's see, minus 3, 2 cosine of x equals negative 1. So we want to know where the cosine of x equals negative half. And you'll notice our domain restriction is just in one full circle. So cosine is our x. So here is negative half. So that means this is root 3 over 2. So that means our angle is pi over 3. So it would be pi over 3. And I don't have to do the 2 pi k because we just want one circle. So that would be 2 pi over 3, right? It's in the second quadrant. And then in that one, in the third quadrant, is 4 pi over 3. Now, we're going to talk about how you get rid of a square. So, a couple things. If you're squaring sine, it's got to be written one of these two ways. It is not the sine of x squared, okay? And then we solve it the same way we do with squares. We solve by taking the square root. So number 6, we want to find the zeros, right? The function is given by this. What are the zeros? So where does 0 equal negative positive 3 minus 4 sine squared of x, and just in one full circle. So I can subtract 3, negative 3 equals negative 4 sine squared of x, divide by negative 4. So now I have 3/4 equals sine squared of x. Take the square root, and we square root the top and bottom. So the square root of 3 over 2, and we have to remember it's positive and negative equals the sine of x. So on this one here, we can have it positive or negative. So any of these, right? Because that's positive root 3 over 2, and down here is negative. Well, what is our reference angle here? It's pi over 3. So then that first quadrant, pi over 3. This would be 2 pi over 3. 4 pi over 3. And 5 pi over 3. And again, if you're getting stuck on some of this, we're going to kind of want to talk about this because this is from our previous stuff. So the only new part is going in reverse. But if you're like, Miss Husing, where do these pi over 3 stuff come in? Make sure you come talk to me. All right, so what are all the values that these equal? So where does the cosine squared of theta equal negative cosine of theta? Well, let's get everything on the same side. So plus cosine of theta plus cosine of theta. So we have the cosine squared of theta plus the cosine of theta equals 0. And now we can factor out a cosine. So cosine of theta plus 1 equals 0. And then just like solving a quadratic, right? We said each part equal to 0. So where does the cosine of theta equal 0? And where does the cosine of theta plus 1 equal 0? Well, cosine is our x, so here and here. So that would be pi over 2 and 3 pi over 2. And this is where's the cosine of theta equal negative 1. Well, that's our x value right here, so it would be at pi. And number 8, here's two equations. In the xy plane, what are the coordinates of intersection? So where does 2 sine squared of x equal the square root of 3 sine of x? So again, let's set it equal to 0. So 2 sine squared of x minus the square root of 3 sine of x equals 0. And now I can factor out of sine of x. So the sine of x times 2 sine of x minus the square root of 3. And then we set either part equal to 0. So either the sine of x equals 0 or 2 sine of x minus the square root of 3 equals 0. Well, sine is our x value, so here or here. So at 0 or pi. And let's see, if I solve this, add the square root of 3 and divide by 2. So the sine of x equals root 3 over 2. So that would be here, right? Those are our y values. So I know that this is pi over 3. And in the second quadrant, it would be 2 pi over 3.